Okay, now let me explain quiz 7. So first, let me see how one of the two tutorial groups performed. So question 1 apparently turned out to be very hard. So only 25% students chose the correct answer. So and 55% chose one of the incorrect options. So apparently it was more attractive than the correct answer. So questions 2 and 3 were challenging too. So about 80% of students answered it correctly. Well, question 4 was very easy. And question 5 apparently was challenging too. So 35% of all the students picked the correct answer. So let me go through these questions one by one. So since 2 were particularly challenging out of 2 questions out of 5 were particularly challenging. Okay, so let us see. So now I'm going to pretend that I'm taking this quiz. So okay. So question number 1. So an artificial neural network for regression with 3 layers is defined as follows. So we have the one hidden layer, one output layer, and then we need to calculate the output for the given input. Right? So how do we do this? Okay, so let me remove this and get the whiteboard. So my layer 1 is input, right? So my layer 1 is input. So my layer 2, so let me just write 2, is the hidden layer. So how do I calculate the output of my hidden layer? So first I calculate this Z2, sorry, Z1. So this is the bias vector in the hidden layer, which is -1, 2, plus the weight matrix, -1, 0, 0, 0, 2, 1, times the input. And the input is 1, -2, 3. Okay, so let me calculate this. This is going to be what? The first row of the matrix times the input is -1, right? Yeah, plus 0, plus 0. And the second row is 0 times -1, so -4 plus 3, so -1. Plus the bias vector is -1, 2. And this is -2, and 2 minus 1 is 1. Now, this is the output of the linear transformation. Now we need to apply the activation function. So A1 is going to be a ReLU function applied to this, which means that we change negative numbers to zeros. So -2 is changed to 0. Okay, so this is the output of the hidden layer. So now we've got to pass it to the output layer, so which is layer 3. So layer 3 is, so we take -3 is the bias, plus 5 times 0, plus 1 times 1, which is -2. Okay, and then we need to apply the activation function in the output layer. In the output layer, the activation is identity, right? So this is an artificial neural network for regression rather than for classification. So the identity is just the same thing. So this is the answer. Okay. So I guess probably a lot of students just forgot to apply activation function, and that's why they got an incorrect answer. So the correct answer is -2. Okay, so an artificial neural network has the following layers. Input layer with 9 units, 4 units, then 20, 5, and 1, and so on, right? So this is, how do we do this? So basically we just take this number plus 1, 9 plus 1, which is 10 times 4. So this is 10 times 4 plus then 4 and 20. So 4 plus 1, 5 times 20. So 5 times 20 plus 20 and 5. So 21 times 5 plus 21 times 5 and plus, sorry, 5 plus 1 times 1, so plus 6. So this is the answer. And this is, as far as I remember, okay, let me calculate it. So this is 80 plus 100, 80 plus 100 plus 105 plus 6. Sorry, 40. 40 plus 100 plus 105 plus 6. So this is apparently 251. I think, yeah. So 251. So for which of the following problems do we need to use softmax activation in the output layer, right? So softmax is multi-class classification, right? So we need to figure out which of these is a multi-class classification. And if you read it carefully, you will understand that it's the second option. So label photographs, because in the first option, identifying whether each of the following instruments is played in a music track. So every one of these instruments can be either present or absent. So it's not like a guitar. If there is guitar, then there is no drum, right? So both of them can be there. But when we label photographs according to these 5 classes, then it's precisely one of these labels. So we use softmax for this, and for the first, we would use a sigmoid activation, but we would have 1, 2, 3, 4, 5, 6 sigmoid units. So 4, everyone answered correctly, so I'm not going to spend time on this. Yeah, this is exactly the same question as was in lecture quizzes. So I guess that's why it is not challenging. So the correct answer is that each model has its own optimal learning rate. Okay, and number 5, somehow there were a lot of incorrect answers. Now let me explain what we see here. So looking at the loss function, we see that training loss always goes down, which is just as expected. So it's by definition of gradient descent, it decreases the training loss. But validation loss can go down and then go up. So, and you see it goes down and then goes up. So, and this is the sign of overfitting. It means that after this point, our model tries to really fit the random noise rather than the patterns in the data. So this is overfitting, and in order to prevent overfitting, we introduce a regularization. How do we introduce a regularization? So we can either but basically, to introduce regularization, we use the dropout layer. So another way is to use L1 or L2 regularization. So, but since the dropout layer is one of these options, we choose the dropout layer. Okay. So that was all about quiz 7.